So in this problem, we have a geometric progression where the terms are increasing. Few conditions are given. It's mentioned here that the first and the last term adds up to 66. And also, the product of the second term and the last but one. Last but one means the second last term, so the product is 128. And also, the sum of the terms is 126. We're using all this information, we need to obtain the total number of terms that's present in the progression. So let's begin. So we will first specify the first term as well as the common ratio. So let the first term be, we're going to represent it by the letter A in lowercase, and then we are also going to specify the common ratio. So the common ratio be represented by the letter R. And we'll assume that there are n number of terms present in the progression. Let's note down whatever is being provided to us. So it's given here that the sum of the first term A and the last term, so the last term is the nth term, which is a r raised to the power of n minus 1. So the sum is 66. Let this be equation number 1. Then we have the product of the second and the second last term. So the second term is ar multiplied to the second last term, which is ar raised to the power of n minus 2. So this is 128. So this is number 2. And then we have the sum of the terms. Sum of the term is Sn value, so that's 126. Fine. So let this be number 3. We'll come to number 3 later. First we will use equation 1 and 2. Fine. So here we have, so let's start with equation number 2. So we have a times, so r multiplied to r times n minus 1. So that's r raised to the power of n minus 1. So this is equals to 128. We also have a here. So a times r raised to the power of n minus 1. So this value is equals to 128 divided by a. So let this be equation number 4. So we will substitute equation number 4 in equation number 1 in place of ar raised to the power of n minus 1. So equation number 1, so this gives us a plus 128 divided by a. So this value is equals to 66. So here we have used equation number 4. So let's solve this equation and find the value of our first term a. So multiplying throughout by a, so we have a squared plus 128 equals to 66a, which will be a squared minus 66a plus 128 equals to 0. So using standard method, we can factorize this quadratic equation. So this will be a minus 2 multiplied to a minus 64. So that will be equals to 0. So that means a could be either equals to 2 or it could be equals to 64. So now that we have obtained the value of a, so we can now easily find out the value of the common ratio r. For that, we can use either equation 1 or you can use equation 2 or even you can use equation 4. So let's keep things simple. We'll use equation number 4. Right. So equation number, let's keep a note of equation number 4 here. So when a value is 2, then we'll use this particular equation. So we have 2 times r raised to the power of n minus 1. So that's equals to 128 divided by 2, which is r raised to the power of n minus 1 equals to 128 divided by, so we'll cross multiply the 2 from the left hand side with the 2 in the denominator on the right hand side. So that will be 4, which will be r raised to the power of n minus 1 equals to 32. And when a value is 64, then in that case we have 64 times r raised to the power of n minus 1. That's equals to 128 divided by 64. So we have r raised to the power of n minus 1, which will be equals to 1 divided by 32. So we are getting two values of r raised to the power of n minus 1. Now clearly, we will be rejecting this particular value. We're rejecting this value because at the beginning of the problem, it was mentioned that our geometric progression is increasing. So this is the only possible value, that r raised to the power of n minus 1 must be equals to 32. So we will be using this value, r raised to the power of n minus 1 equals to 32, to find out the value of n. So let's use equation number 3. So we already mentioned at the beginning that the sum up to the n terms, that's given as 126. We know that since it's a geometric progression, the sum to n terms will be given by a times r raised to the power of n minus 1 divided by r minus 1. So that's equals to 126. Right. So we already obtained this value. So we have a equals to 2 and r raised to the power of n minus 1 equals to 32. So we can rewrite this equation. So we have a times r raised to the power of n can be also expressed as r raised to the power of n. So we'll subtract 1 from it and we're going to add 1 to it. Minus 1, which will be equals to 126 multiplied to r minus 1. So a value that's equals to 2. So we have 2 times r raised to the power of n minus 1 multiplied to r minus 1. So let's write it in this particular fashion. So this will be equals to 126r minus 126, which will give us 2 times. So r raised to the power of n minus 1. So that's 32. So we have 32r minus 1, which will be equals to 126r minus 126. So 2 times 32r, that's 64r minus 2 equals to 126r minus 126. Well, combining the like terms and rewriting the equation, so we're going to get 126r minus 64r. So this will be equals to 126 minus 2. So 126r minus 64, so that's going to be equals to 62r, which will be equals to 126 minus 2, that's 124. So r value will be equals to 124 divided by 62. So 62 times 2, so that's 124. So we have obtained our common ratio, r is equals to 2. So now that we have the value of the common ratio, so we have a equals to 2 and our common ratio r, that's also equals to 2. We can use this information to obtain the number of terms present. So let's use equation number 1. So in equation number 1, we had the condition that the sum of the first term and the last term, ar raised to the power of n minus 1, that equals to 66. So our a value is 2. So we have 2 plus 2 times 2 raised to the power of n minus 1 equals to 66. So we have 2 times 2 raised to the power of n minus 1. So we're transposing this 2 to the right hand side and subtracting it from 66 to get 64, which will be now 2 times raised to the 2 raised to the power of n minus 1. So we're dividing both sides by 2. So that's going to give us 64 divided by 2, that's 32. So 32 is 2 raised to the power of 5. So equating both sides, we have n minus 1 equals to 5 or n value equals to 6. So that means here we have n equals to 6. There are 6 terms in the given geometric progression.